Hey guys, how are y'all doing? I hope everybody had a good day and is ready to start their homework. Tonight you need to complete 4 problems instead of 3 like the previous nights. So you will need to complete questions 7, 8, 9, and 10. On the first problem, the lesson standard is to be able to write fractions as a sum of fractions. But in order to do this on this problem, you also have to know how to determine fractional amounts in objects. So, for example, in this problem, you guys need to find out which one of these equations does not represent the stars and candy canes. So we need to make sure that we're being very good, strong readers as well, because the question's only referencing 2 of the items that you see in this picture. So, for example, if I were to have a similar problem where I have various different pictures in a set, I could look at this picture and know that I have a total of 9 objects. So that would be my denominator of a fraction would be 9, because the total number of objects I have are 9. So if I want to know what the fraction of my smiley faces are, well, there's 3 smiley faces out of the set of 9 objects. Okay, and my hearts would represent 1, 2, 3, 4 out of the 9 set of objects. And then my squares would represent 2 out of the 9 objects in this set. So think about that as you are solving this problem. You need to be able to show, so first you need to determine, well, what is the fractional amount of the stars and candy canes? And then determine what would that look like as a sum of fractions. And then you would need to pick which one of these does not represent the sum of the stars and the candy canes together. Okay? All right. On number 8. 8 is this learning standard where we are using benchmarks to determine reasonableness and to kind of estimate fractional amounts. So in this problem, we have Cam's mom, and she told him that he could spend 11/12 of an hour playing outside, and he's already spent a fourth of an hour playing outside. So we want to know what would be a good estimate of the amount of time that he still has left to play outside. So for example, let's say that in this situation, we have somebody whose mom told him that he needs to do his homework for 8/9 of an hour, and that he needs to spend 8/9 of an hour doing his homework. And let's say that so that's going to be how much time he is going to spend doing his homework. And let's say that he's already spent 1/2 of his time doing homework. And we want to know about how much time he has left to do his homework. Okay? So let's talk about that. So one of the things that we need to know is our fractional benchmarks. So if I draw a model, I'm going to go ahead and draw a model of 8/9. Okay, and let me go ahead and separate this into ninths. So there would be a third. So, wait, that's not going to be a good model. Let me try that one more time. So 1, 2, 4, 5, 6, 7, 8, 9. Okay, and he needs to complete homework for 8/9 of that period. I'm going to shade in 8 out of the 9 parts. This is how much time he needs to spend doing homework. It's a lot of that's 8/9 of an hour doing his homework. Okay, that's how much time he needs to spend doing his homework, right? And he's already spent 2/9 of that time doing homework. So I'm going to shade what he's already done. Okay? He's already spent these 2/9 of that amount of time doing homework. So we want to know about how much time he has left doing his homework. And we need to think about how much time he has left based on our fractional benchmarks. So if we think about our fractional benchmarks, this point right here would represent 0. This point would represent 1. This midpoint would represent half. This would represent about a fourth. And this would represent about 3/4. Okay? So look how much time he has left. Okay. So 1/4. So I would say that this would be about a 1/4 amount of time right here. And this would probably be another 1/4 of time. So a 1/4 and a 1/4 equals a 1/2. Okay. So I definitely see where he still has quite a bit of time left to complete doing his homework. I can see that it's definitely more than 0. This amount of space occupies more than 0. When I look at about how much half is from here to here. He definitely has more than half of the time left to complete the homework. So think about that as you're trying to make a decision on about how much time Cam has left to complete the homework. Okay, that's a little tricky, but I know that you can do it. Try your best. Okay, on the next one, we are using a number line to represent how to add mixed numbers on a number line. And you're looking for which one of these answer choices does not show how you could add these 3 mixed numbers on the number line. What I want you to keep in mind and to think about as you're solving this problem is I noticed that the denominator in the fractional parts of the mixed numbers are all 5. So that's a 5, that's a 5, and that's a 5. So that, but I also see that we have whole numbers, 1, 1, and 2. So that's why you're going to see that we have whole numbers on our number line, but in between our whole numbers, because our denominator is a 5, there's 5 equal parts. So I notice that between 0 and 1, there's 1, 2, 3, 4, 5 equal parts. Between 1 and 2, there's 1, 2, 3, 4, 5 equal parts, and so on and so forth. So we're counting by ones, whole numbers, because we have mixed numbers with whole numbers, but in between we're counting by fifths because the denominator in the fractions is fifth. Now, if you're going to add mixed numbers, if I were to have like 1 and 2/3 and 2 and 1/3, and let's say I wanted to, add another 3 and 2/3, then this can be done in various ways. You could add your whole numbers first and get 6, and then you could add your fractions next, and you would get 2, 3, 4, 5, 5/3. Okay? Or you could add your fractions first. You could take 2/3, 1/3, and 2/3 and get 5/3, and then add your whole numbers, 1, 2, and 3, and get 6. Okay? So you could do it that way. And so when you are looking for the number line that does not represent this, you need to understand that when they're making these jumps, they can add the fractions first, which I see has been done here. You can add the fractions last, which I see has been done here. You can add your whole numbers first, which I see here. They're actually adding the entire mixed numbers and making those jumps. Okay, but whatever the jumps are that they make, the jumps have to represent part of those mixed numbers. So they could make a whole jump there, they could make 2 whole jumps there, they could make a whole jump there, or they could jump 4/5 there, a 1/5 there, and 2/5 there, or the other way around. But whatever their jumps are, they have to represent these numbers. So I can see that one of these, the jumps that are made, do not represent these numbers at all. So be thinking about that as you solve your problem. And then on number 10, you are trying to find, using the fraction strips, you are trying to find which one of these fractions is not equivalent to 2/3. So I would locate 2/3. Well, here's 2/3. It goes to this point. So when I go down my fraction bar, my fraction strips, I notice that there are several other fractions that would be equivalent to that. Here would be an equivalent fraction to 2/3. Here would be another one, and here would be another one, but there's some that are not. So I would shade in, if I were you, shade in 2/3, and then go down your list and see if you were to shade in that same amount of other fractions, which one of these would not be equal to that 2/3. Okay, I hope this helps. If you have any questions, you can always shoot me an email and I will try to respond to you as soon as I can. Thanks.